Today we're going to look at composition of, and algebra of functions. So what is the purpose of these topics? So think of a function as a reusable algorithms or as reusable. When we write a function, we preserve what it indicates and what it does. So, compositions of and algebra of functions allow us to combine functions to do new things. And if you're wondering, again, is this just an algebra thing or a math thing? The answer is no. I mean, both concepts are extensively used when you're writing computer code, as an example. So if you ever do that, you would see that you're using this idea constantly. So let's look at algebra of functions first. So there's two parts. There's algebra of functions and there's composition of functions. What this means is that we're going to combine functions together via the basic operations of, addition, subtraction. Care to guess what the next one is? Yep, if you guess multiplication, you're right. And division. And you've already done this. I mean, you have literally done this in prior courses in the guise of subtracting, adding like terms. What else? Simplifying division. And I'm having a hard time spelling at the moment. So just simplifying division. And applying the distributive property. Which involves multiplication, right? So like terms that come by adding, subtracting, simplifying and division, all these you've done before. But we're now going to take a look at this notation that kind of indicates what we're doing, and it's important to really focus on this notation. We're going, let's understand the symbolism. First of all, if you look at this, it says f plus g of x. So what does this mean? It literally means add these two different functions. So here and on the right, I'm going to write the literal meaning of this symbol. It means find this f of x and add it to this g of x. If I wrote this, f subtract g of x, then that is indeed what it sounds like. Subtract these two. So this symbolism right here, the first one, tells you the act of what we want to do. And this is obviously trying to actually do this act. And right here, there's a little dot missing here, but this means multiply. And you see a little tiny dot. And this really means f of x times g of x. And again, remember the f of x is an entire symbol. You can't take it apart. So putting them both together just means to multiply these two functions together. And this means divide f divide g of x. So really it means f of x divided by g of x. Okay. So that's the meaning of these four that we're going to look at. So we want to do two things in this case. I'm giving these two functions and I want to find f plus g of x. And then determine the domain of this new function. So we'll do two parts. So here's again the way I would like you to write it. This is the way I'm going to grade you on a quiz or an exam. So if you're being asked to do this, then write down that symbolically. So maybe you will do something like this. This lets the reader know that what you're about to do. And this next part kind of helps you out to remind yourself what this is about. And now that you've written that, equal sign and below. Do not do this. Don't go across like this. This is no good. I want you to go downward. Okay, so no going across. So now I'm going to put this function together here. 3x plus 7 And then I'm going to add the next function, which is x squared minus 1. And the only thing left to do at this point is add like terms, and I'm going to rearrange these in order. So the only like terms is the 7 and the -1. So I'm going to come over here and write just x squared plus 3x, and then I'm going to compute 7 subtract 1, which is a 6, and I am done. All right, so I'm done with that part. Now let's talk about the domain part. Now I want to find the domain of this function. So to find the domain, determine first the domain of f of x. So what is the domain of f of x? In this case, I'm looking at this. This is a straight line. So the domain of f of x is everything, -infinity to infinity. Okay. What about domain of g of x? And again, I have a quadratic here, x squared plus 1. And again, this is -infinity to infinity. Since there's no restrictions for either of these, then adding them together has also no restriction. What if this one had a restriction that wasn't everything? Then you take, again, what's common to both in this case, because you need both to be able to accept the input. But in this case, the domain of f of x plus g is all real numbers. So -infinity to +infinity. Okay, there's no restrictions. All right, let's look at another one here. This says to find f divide g of x. So again, I'm going to write this down. Then actually show a little more detail what I'm about to do, which is divide the two functions. So I'm going to put 3x plus 7 on the numerator. And in the denominator, I'm going to put x squared minus 1, representing g of x. Okay. And are you done? Yeah, practically you are done. But remember, like if you look at prior courses, so you might recall that you would have factored this as much as possible and reduced if possible. So I'm going to just factor this as a reminder. How do you factor x squared minus 1? Well, again, I don't know if you recall, but this factors into the following. And how do I know that? Well, I remember this is the difference of squares. And again, you can try this on your own, but when I'm looking at this as x squared minus something squared, in this case, 1 squared. So this factors into x, sorry, x, not x. A, and not squared. Sorry. Oh, you couldn't even see my mirrors. Excellent. A minus b, a plus b. Okay, so that's what those factor into. Okay, and again, if you don't believe that, then multiply this out and you'll see that you get this back again. But that's something you can try on your own. All right, so we got this figured out. And again, we ask ourselves, what is the domains of these things? So let's look at the domain of f of x. And again, it's a linear equation like we already determined. It's just -infinity to infinity. Okay, so in fact, we already did g, it's the same function we did above. And again, it's -infinity to -infinity. Now, so that's what we have. Both of these are all real numbers, but unfortunately, this is sitting in the denominator. And we cannot have this denominator equal 0. So I will set this equal to 0. Okay, solve. Add 1 to both sides. Next, take the square root of both sides. Notice that each time, well, I'm not actually showing the adding part, I'm showing the result of that. Once I do that, I'll leave this alone. Now, the next thing I'm going to do is take the square root of both sides, but I'm going to leave this alone. So if I'm following later, I can see this these two connected, and I realized, oh, okay, yes, I added 1 to both sides. Now I'm going to take the square root of both sides. And again, remember, because you're taking the square root, you need to add a plus and a minus. There's 2 possibilities here because you're trying to find all solutions to this. So when I do that, I get x, square root of x squared is x, and square root of 1 is 1. So there's 2 things that this can't have. It cannot be a 1, and it cannot be a negative 1. Because again, these f and g alone don't have any restriction. The only restriction is the denominator restriction. So it's not the function restriction, it's denominator restriction. So now what do we do? Well, we now put everything together, the domain of f g f divided by g of x is, and again, we do it very step at a time. So notice again, it goes from -1 to 1. And again, if you're kind of having a hard time visualizing it, maybe drawing a number line here might be good. And again, I'm going to put this no good. Everything else is fine, except it cannot be a 1. It can be about -1. So now it was help me in writing my interval. I go from -1, negative infinity to -1, don't include it, union, -1 to 1. Okay, and then from 1 to infinity. And there's my domain. So